One of the things that I think you're really awesome at, and we'll talk about this later in the conversation, is explaining kind of material science concepts. You have this awesome LinkedIn kind of snippet you do kind of weekly now on metallurgy. But for those who are listening who may not be familiar with some of the terms, like, can you kind of describe what does it mean to be a ceramics engineer? I mean, I know you didn't kind of focus on that ultimately, but kind of from a material science perspective, what do you mean when you say ceramics? What's kind of an easy way for people to remember that?
Yeah, so I guess ceramics is more focused on oxide materials. My dad always described it as inorganic non-metallic. They basically just defined it by what it was not. So it wasn't polymers and it wasn't metals, which isn't necessarily the best description, but it ends up being all these materials that are very complicated, whether it's like silica with its goes into like glass and all kinds of more complicated ceramics materials. There's kind of like the traditional ceramics, pottery, right, goes back thousands of years. I don't know when glass got invented, but then there's like all kinds of modern things, right? Computer chips and things like that are based on ceramic systems. But yeah, thanks for bringing up my new thing, Metallurgy Monday, trying to explain that. I think partly because I see a lot of things that annoy me because they're like factually wrong. And it's clear that like a lot of people have no exposure to that. I guess the one thing that I kind of look at with whether it's ceramics or materials or metallurgy, a person tends to be very broad in the engineering fields, but then very deep in like that area. So we learn about, the mechanical aspects or the electrical aspects or what's happening chemically and all kinds of things like that. But it's all focused on a given type of system.
Yeah. It's so funny these days when like we go to these additive events and you're in a room and a lot of the technical talks, there's 5 or 10 other materials engineers in the space. Like it seems like there's such a density of people that are kind of coming from a materials background in working in additive now, but with kind of the work you're doing, kind of jump into the Metallurgy Mondays is like you almost take it for granted if you come from a materials background of like the nuances of some of the terminology, some of the conceptual understanding of like, what does it mean to be a metal and what are phase diagrams and all of this stuff that you study in school, but then as you get to apply it in everyday manufacturing, it's something that is certainly important, but to understand and apply, but then also how to communicate that effectively and what are the implications ultimately of okay, so what does it mean to have this as a phase diagram or other term?
Yeah, and I don't know what people learn at other universities. I know at Ohio State, almost all the engineers, at least at that time, had to take a 1 quarter long, so like 10-week, so maybe 30 classes, very introductory level materials class, but it was a very broad survey and they didn't really go into like any depth. So they'd be like, this is a stress strain curve. This is how you read them. And it was very, very basic. And I think a lot of engineers either they never even had that, or if they did, they don't remember or can connect the knots between, the designs that they're doing and things like that. So yeah, and I do agree that there are definitely often a lot of materials people, which has not been my experience in a lot of places. There are often none in the room.